Good morning. Good morning. All right, we've got the mic. Good, good, good. So this is part two of Skynet Revolution, episode one on Code and Game. Already started working on that solution last Friday, I think it was. And we're going to keep going with that today. So let's get in there. And bring in our file from our local machine, upload from local file. Good. Now we're in synced, and we can work from our preferred ID. Good. All right, so I gotta kind of get back into this. It's been a few days. What we're trying to do here, just a quick recap. If I go back here, we're working with graphs and the breadth first search algorithm. And that's basically kind of a little game where we have to sorry, seasonal allergies. Okay, so we've got a simple example here. Our job is to sever links in the network. The red here represents the Skynet agent. The blue represents a gateway, and the Skynet agent is trying to get to the gateway, and we get every turn to sever a link between two nodes. So we have to come up with an algorithm, kind of an AI, if you will, that will determine the best link to sever to prevent the Skynet agent from getting to a gateway. The game ends when the Skynet agent is unable to get to a gateway. So we've severed it every possible ways to get to for the agent to get to a gateway, or the game ends if we let the agent succeed in getting to a gateway. So if I remember correctly, what I was trying to do was implement a graph. That was pretty obvious that that's what we needed. And I don't think I was done, but I was implementing the BFS algorithm, breadth first search, which starts at the user agent, not the user agent, what's called the Skynet agent. We'll just call it the agent. It starts at the agent, looks at every possible node until it finds a gateway, and that is basically, doing that. It stores the information along the way, and it figures out which path is the quickest to get there. So once we have that information, then we can simply choose to sever a link along that path, and I would think that the most logical thing to do is to sever the link on that path that is closest to the user agent, is my thinking anyways at the present. It might get a bit more complicated than that as we add more gateways, because there is the possibility of more than one gateway in the network. All right, so let's take a look at our code so far and try to figure out where we left things off. Main here, are we doing anything special in main? We're just getting our starting input, and we are network add link. Okay, so we're creating our network, our graph. What am I doing here? I'm not doing anything with this here. Console log error networks. Okay, so I'm just logging the network, probably just for diagnostics right now, as we're not. This is the game. So yeah, I hadn't started any the actual game and dealing with that yet. So I think I'm still in the process of making sure that my network is constructed properly. So why don't we do that and run Run the first one here, see what happens. Okay. Oh, right, that's correct. Starting input, we're getting, oh, would you look at that? The screen, oh, this is really cool. It shows us basically turn by turn what's happening. Okay. So, if just take a look at the input we're getting here. First we're getting a line that says, okay, you're going to get 4 nodes, 4 links, 1 gateway. Then we proceed to getting our links. So node 0 to node 1 is a link, node 0 to node 2. I think I deal with all that yet already because I've got the code to do my network. So, okay, and this is basically just a little representation of that. I think I'm logging somewhere along the way. So we're basically getting 2 links here at the beginning, which is, you know, correct. Node 0 links to link to node 1. I'm going to guess this is node 1. Oh no, this would be node 1. So node 0 links to 1 and node 0 links to 2, right? Node 1 to 2, node 1 to 0. Okay. And then this is my graph. These are my nodes. So there's 3 nodes, so we know that's right. Oh yeah, we have to mark if we're okay. Connected nodes that we don't see, but okay, let's take for granted that we've hooked up everything properly for our network. Well, let's take a look. What are we doing here? I have a class node and I have a class graph. Okay. In my class graph, I have a nodes array that contains nodes. This is my class node. What do I do in there? I have a marked property. I have a connected nodes property, which is an array of numbers. So this will be only the index of, let me just turn that off here. Okay. There we go. Okay, so if it's an array of number, I'm probably just storing the node's index in the node's index in this array here. That might be sufficient for now anyways. Is marked means that's probably something that when we iterate through in our breadth first search algorithm, we mark the nodes that have been processed. This is to get the connected nodes, so connected nodes values. So that returns an iterator. Okay, we'll probably do something with that in the graph class. And okay, just a method to add a connected node, so that just pushes to the array, and a method to remove this. What does this do? Node index equals this connected nodes dot index of connected node. Disconnected node splice node. Right. Because we're being passed the number. I need to find the number in my connected nodes array and remove it, and that's what we're doing here. All right. In place. Okay. Now, what happens in the graph? Add a link. And okay, so yeah, we have to, if we're adding a link between node 1 and node 2, we need to make sure that we're adding, because it's a bidirectional graph, right? So it's not only a link between node 1 and node 2, it's a link that goes from node 2 to node 1 as well. And that's basically what we're doing here, okay? And if we ever have to remove, we have to make sure we're removing it in both. Yes. Okay, and this would be my breadth first search method, which obviously is not complete because it's not returning whatever it needs to return. I'm getting it to return an array. Oh, it's a tuple, whatever. Of what? The link between the 2 nodes. Okay. Q. Okay. So that's the Q. As we're going down, we start off with our agent's node. We mark it as processed. We actually process. Okay, that's what we're missing here. We're not really processing it. But we've got the BFS algorithm implemented, the core of it anyways. Right? We're looking at for const node index of q0.get connected nodes. That's right. So we're looking at each child. I don't know if we can say child because it's a graph. It's not a tree. So connected nodes, right? We're looking at connected nodes. But I'm storing them just as indexes in each node class. So I'm actually getting the node here by using the index, okay? This dot nodes, node index. If connected node is marked, so if we've processed it, then we just push the connected node onto the queue. That doesn't seem right. Let me just take a look here. I've got a quick, let me try to put it on here for you guys. Found this nice little book with all kinds of algorithms. I think this is the one we're looking for. Breadth first search. If not marked, right, so I got that wrong, of course. Spotted that right away. Let's do this and that just for now. It's going to be hard for you guys to see that. I'll just keep it on the my other screen here, and you'll just have to imagine what I'm looking at. But I'll tell you guys. All right, so I think we've implemented this correctly, except for is marked. So what we need to do is if it's not marked, so if it hasn't been processed yet, then we push it onto the queue and we mark it. Yes, 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 that seems right. Then we're done with our if statement, then we're done with our for loop, then we dequeue, so we remove. I don't really need a space here, do I? We remove basically the current node, the node we were dealing with. And we keep going as long as there's stuff in the queue. And there should be, as long as there were connected nodes, right? Because we just pushed them if they weren't processed yet. I think that's right. I think that's right. And that will get us to go through every node in the graph, which, you know, is not really efficient, but I think we had determined that the size, the max size of the graph was 500 nodes, 1,000 links. So I think performance-wise, we don't really have to worry about it. We'll see when we actually start getting into some of the bigger graphs, but I don't think we have to worry about that. Now, okay, so what we have to implement here is what are we actually doing with each node that we're traversing? What are we interested in? Well, what we're interested in is keeping track of what we're interested in is keeping track. Yeah, that's right. So we're basically doing pathfinding here. So we're implementing breadth first search, but it's closer to what's it called? Dijkstra, whatever algorithm. So what do we? I don't really remember what we need to store. We need to store. Oh, that's right. We need to store the okay, are we doing that? No, we're not doing that. So in the node, we need to store the predecessor. How did we get there? Right? So, because we need to keep track of the path. So how did we get there? Just look at my little book that I found here. I think there might be a pseudocode listing for the algorithm I'm looking for here. Because yeah, I know we need to keep track of the path and basically the value, the weight of that path, like how long is it? So as we're traversing each node, we need to basically track how far is this node away from the parent node. Something like that. Using the shortest path, right? Because there's nodes that you might be able to get to different ways. Recursion, trees, graphs. That's where we were. Pathfinding. I'll just put it here for now as I'm looking through it. Okay, see, the breadth first search. 17.1, and making a smarter pathfinder. And that's probably something like the Jigstra. I have to figure out how to pronounce this. DJISTRA. I think it's some dude's name that invented that algorithm, but and a bunch of other stuff. Can you tell that I haven't actually taken a CS class? 721. Pathfinding. Breadth first search. Remember the breadth first search from chapter 17? That's where I was just before. Turns out that this searching algorithm is a very basic method for searching for the shortest path through a map of a graph. Remember the algorithm first process all of the cells that are one jump away from the starting cell, and then every cell that is 2 jumps away. Yeah, that's right. To apply this to pathfinding, the algorithm stops when the goal is found. Right. We could implement that, I guess. It would be more optimized. Do we care about optimizing right now? Not that much. Here's the algorithm described in pseudocode. Remember, the breadth first search requires a queue to work. Note that the cells also require a new variable. And by cells, he probably means nodes. Yeah, okay, like cells in a map, tile map. Okay, next page. New variable. The previous pointer. It tells each cell which cell pointed to it during the search. Yeah, that's right. It's my predecessor, I was saying. I make that clear in a moment. So, add the starting cell to the queue. That's what we do. Mark the starting cell. Take the first, let's follow along here. And that's basically what we're doing here. Just leave it like that. So, add the starting cell to the queue. Boom, that's what we're, oh no, that's going to be annoying. Okay. Mark the starting cell right there. Take the first cell off of the queue right here. No, right here. Right. Actually, const q this dot nodes while q dot length for node of q0. Yeah, that's what I'm doing. I'm taking the first cell off of the queue. Well, I'm not actually doing that. This is where I'm taking it off the queue. But I could do q.shift right here. would make sense instead of doing it like that. I wouldn't have to do it there, but let's keep going. Take the first cell off of the queue. If the cell is the goal, then the algorithm is complete. We might implement that, or I might just let it run through the entire graph. I don't know yet. If any of the children aren't marked, set their previous pointer to the current cell and add them to the queue. Now this is something we're going to have to add. Go to step 3 until the algorithm is complete or the queue is empty. So make the first cell, go. So basically all we're doing is keeping a pointer, right? We're keeping a pointer to the previous cell. Let me take you through this algorithm one simple step at a time. When a cell's added to the queue, it is turned light gray. So that's our starting. That's our end here. Oh, let me see if I can zoom into that. There we go. Let me take you through this. Okay, when a cell is light gray, this is what we're trying to do. Whenever a cell is not in the queue but is marked, it will be dark gray. Okay, each cell in the queue will have a pointer to the previous cell. Figure 23.9, which is this here, shows the entire process of the breadth first search level by level. Yes, so starting cell, we look at all of them, we mark them, then we look at all of the next ones, we mark them, dark gray, then we look at the other connected ones, boom, so on and so forth, until we get to our goal. Okay. Oh boy, he really is taking us through the info. Modifying the BFS pathfinder. The plain breadth first pathfinding algorithm has a few flaws. First of all, it treats all adjacent cells as the same distance away from the center. Okay, that's not a problem with us. We're not actually moving in a real environment on a tile map, so we're not going to worry about this. Zoom back out if I can. Maybe I can't. Here, okay. Come, this works, but that's weird. Huh. Control +1, Control ++. Wow, that is weird. Okay. Now, but how do we... Wait a minute. How do we know the shortest path? Oh, that's the thing. Oh, I guess this would work, right? Okay, so I'm just thinking, I'm thinking too far ahead, but because our current test case only involves one gateway, but I was thinking, what if we have more than one gateway? But actually, if we're doing this, the minute, since we're always going just one away from, and then two away from the starting point, the first time we hit a gateway, that's going to be the closest one. We don't need to find the other ones. Not really, right? So yeah, we do want to short circuit that thing. And as soon as we find a goal, boom, that's it. We know that's the shortest path. We go back up the list of pointers until we reach our first link, and that's the one we remove. Boom. Yeah. All right. We got it. We've got our algorithm planned. So what did we need to do? We needed to store, mark the starting cell, take the first cell if the cell is the goal. But if the cell is the goal, then the algorithm's complete. We'll get back to that one. Okay, if any of the children aren't marked, set their previous pointer to the current cell. That's what we're going to do. So we need to add to our node class a private, let's just call it previous, I guess. Previous node is, or predecessor node. Previous node is good. Previous node. Let's go with previous node. Previous node. Are we? What should we do? Actually store the node? Like the node object, or just the number index? What's the smart thing to do here? Probably the actual node. It'll make it easier to kind of just go back recursively up the chain. I think so. Previous node, but it has to be first we have to make it null. Null would be our parent. Parent doesn't have a previous node. Does that make sense? I don't like doing that, but or just keep it as undefined. Right. When we're creating, it should actually be undefined. Right. When we're creating it, it's undefined. But for the parent, we want it to be null. So previous node can either be a node. It could be undefined when we're creating a node class. Unfortunately, we don't know yet what it's going to. Wait, where are we creating the nodes? We are creating them when we're creating our graph. Okay. But what about the links? Whatever. Yeah, okay, let's roll with that for now. So process node at index 0 in the queue. Now do I want to, I think I'm going to do that. I prefer the way they're doing it here. Instead of doing Q0, get connecting nodes, we're going to do our Q shift right here. Control X, Q shift will return and remove the first object is possibly undefined. Right, because if the array, if the queue is empty, no, it can't be because we've got a check here. So we know that queue is not empty. TypeScript's not smart enough to pick that up. So let's typecast it, I guess. You know what? Let's not. Let's just leave it like that. Now here, okay. What are we doing? If add starting queue, mark the starting cell, take the first cell off the queue, which is starting queue at the beginning. If the cell's the goal, then okay, we'll get back to that. If any of the children aren't marked, set their previous pointer to the current cell. Okay. So in fact, it needs to happen here. If they're not marked, then they're not marked. Then we set the previous pointer and we add them to the queue. So set the previous pointer. We're going to do connected node dot set previous node to be what? Q. Yeah, I don't, okay. So in the end, we might do this then. Let's do our Q.shift right here. Q shift. Interesting. Let's see. We'll call this current node. And it is saying that it could be undefined. So we'll just say as node. We know it's not undefined. It can't be undefined. Can it? I don't see how it could. I mean, we're assigning a node in the constructor here in the graph. We're assigning a new node to every single, yeah, it can't be. So I feel confident with this. We can do that as node. Good. So now we can do of current node. Current node dot get connected nodes. And we can simply get rid of this. Okay. Index of current node, get nodes. Connected node equals this dot nodes. Hey, Common Doc. Thanks for following. All right, if it's not marked, we need to set the previous node. And the previous node that we're setting is the current node, like that. And that's weird. I don't see you as a viewer in my list here. You must be doing some magic or something. I thought I was all alone, talking to myself. Glad you're here. And pushing that, marking it, and then we go back through. All right, good stuff. So now we just need to implement this. Connected node. We are going to, let's see, add connected node, get connected node. Remove connected node, so these are all, let's put it here. Set previous node. Node is a node. Node. Okay, and we're just basically shoving that in there, aren't we? Previous node. Oh, wait a minute. Node. Q. We need to Q node. This node's agent's node is a number. This here is our actual starting node. Let's make this more explicit. Agent's node index, and we're going to do this const dot starting node. Node is equal to this thing here. Right. Then our queue is going to be just starting with the starting node, but now I'm able to, I need to set my starting node, set previous node to null. Our starting node doesn't have a previous node, and that's how we're going to be able to identify it. Although technically we could just use the undefined now that I'm thinking about it, instead of using null and undefined, right? Because as we're going back up the previous node, yeah, let's keep this simple. It's a thing in JavaScript with having both node and undefined, but this will save us some, although this would be more explicit, but whatever, it saves us. Actually, let's just get back to the way we had thing before. I might keep this though. That was good. That's not the actual node, it's the node's index. So that's good. Node index. And we get rid of the null. We're not going to do that. Just keep undefined. All right. We got the agent's node index. What do? We push to the queue the actual agent's node. Then we mark that as, yeah, why don't we just use the starting node? That wasn't a bad idea. Starting node equals this. Like that, then boom, starting node. And here, this dot nodes, I can just actually do starting node dot mark. Okay. Node, we push it to the queue, we mark it. Then we take the, we pop and, no, we don't pop, we shift, we dequeue. That's the correct way with the queue to call it, I think. So we dequeue, and then we look if there's any connected nodes to that. And connected node equal this dot nodes. Yeah, because we're actually getting the indexes, so now we can get the actual node, which makes me think, why don't we just store the nodes themselves instead of the numbers? Where are we doing that? That's the add link. Add link, we're just pushing the numbers that we're getting. So this is where we would have to actually get the node itself, the node object, and push that to our connected nodes array if we wanted it to be the actual node instead of the number. Is there a reason to do that? We would need to store the index of the node in the node object if we did that. Let's keep it like that for now. Okay, so now we're good. We're setting our previous node. Which makes me think because at some point we're going to need to stop. When we're going to implement the algorithm that basically unwinds the path, we're going back up the path. We need to stop at the first link between our starting node and the second node. That's the link we want to remove. So how am I going to get away with... Yeah, I think I'm actually going to have to store the nodes index. Kind of like a linked list here, I guess. Private node index is going to be a number. Actually, here, number. We're going to, let's think about this for a sec. What do we have access to here? Do we have access to, this is a mapping function. I believe we do have access to the index in the mapping function. So this will be that. And then key, that's right. So index is this, then pass in the index to our new node. There we go, we're in business. We just need the constructor to take in the index. It's going to be a number. And we can actually, there we go. Let's do that. Love that little shortcut in. Yeah, just like that, I guess. It's fine. Good. So now we have access to the index. We might as well just make our connected nodes array, not store the index, but the actual nodes themselves. So node, then all this is like, oh, this will work. I'm getting a number. What's going on? Add connected node. Now that the fact that we're getting the index, that's fine. So let's make this explicit. Connected node index. And now that we have that, can we... Oh no, that's the problem because we don't have access from the node to the... So we're going to have to pass the actual node in there. So add connected node. And we're doing that here. Add a link. You're giving us this. And we need to basically do that. If we're passing in the actual node. That's right. Too bad, not too bad. Okay. And of course, if we want to get connected nodes, that's good. What are we returning here? An iterator of nodes, yeah. Add connected node, we've taken care of that. Remove connected nodes. We need to change that. We actually need to... that's interesting. Okay, connect. What are we going to do here? We're going to use the index still, because that's the only way to really differentiate it, I guess. Although I could use a find if we know, yeah, if it's the actual object. Pass in the actual object. Let's try that, see how that would work. If I have, because if we're using find, I think it's using strict equality. So it'll search for it by reference. Will it? Pretty sure it will. But let's just make sure by looking at the docs here. MDN array dot index of returns the first index at which the given element can be found in the array. Element to locate in the array. Compares search element to elements of the array using strict equality. That's right, the same method used by the triple equals. So, and there's probably examples of that with objects in here. Maybe not, I don't know, but I'm pretty sure this will work. We could test it out. Oops. We could test it out, but I'm pretty confident that it'll work. So you pass the node you want to remove. It finds it in the array, and it removes it from our array. Good. Okay, but then that screws up this here. We need to do the same thing we were doing. Boom, like that, like this. There we go. This will take care of this. Right, we're actually getting the node now. So that simplifies things. We can call it connected node right in here, connected node. And then just get rid of this. If connected. Node's not marked, and then do this, do that, blah, blah, blah. This is all good. Okay. And okay, this is what we were implementing here. This is what sparked all of this. So set previous node. You're passing a node here. It's just a setter, basically. Okay, the previous node equals node. There, but all this will allow us to more easily go back up the stack, go back up the, I guess it's kind of a stack, right? It's basically linked nodes. So we've set our previous node. Now all that's left to do is actually look and see if the current node is, if it's a gateway. And I'm probably going to delegate that to another function. But let's implement it. Let's implement it in here. If, and just make sure this works with all, take the first cell off the queue. If the cell is the goal, then the algorithm is complete. Okay. So, yep. If, let's do, what kind of check do we need to do? If current node dot, oh, we don't have it. Okay, so I'm actually going to need a getter as well for our index. And I think that's going to be the first one. Get index here. Actually, I can probably use like an actual TypeScript getter. I think this is how this works. Wondering if I can use one here too. But no, since I'm, but for this one, yep. So get index. Get accessor must return a value. That's right. We're gonna do that. Return, what are we doing? We're getting the index, so let's get the index. The index. I don't have my private here, that's the problem. Okay, there we go. All right. Now we can just get our index. Where if current node dot index is, are we storing in our graph? We've got all our nodes, but we're going to need a, okay, so no, instead we're going to add to our private is gateway. Is gateway. False. That's what we're going to do. So it's simply a matter of doing in here if current node is gateway. Is gateway. Then boom, we're done. We are done. Yeah, that's how we're going to do it. Now, where do I assign the Boolean for this? Probably when we create the graph. Right. I'm going to need to do this when I create the node. How do I know though that it's a gateway? I think let's go back to our inputs here. At the beginning, we're getting number of nodes, number of links, number of gateways. Oh, okay, here. That's the last thing we're getting is the actual index of the node with gateway. Where are we storing that? We are storing that. We are storing that in main. That's somewhere. Right here. Okay. Right here. So, okay. Means I would have to go in here and get my network and actually need to get access with, I actually need to get access to one of the nodes here from the outside. So let's give that. We're going to call this simply get node. Get node. Give me the index, and I shall get you the node. Okay, and then this dot nodes. Boom. Index. Actually, return. Return. That's not nodes index. Okay. As simple as that. From here, we do network. Network dot get node. Give me this node here. Why is it called EI? EI. I don't know what it stands for. Interesting. I didn't choose this. This is a lot of this is like boilerplate code that came with the puzzle. Whatever. It's the index of the gateway. Network gateway node. We get to know. Then we can just right away set. Okay. Need a setter for that too. I need a setter for What should I call this? Set is gateway. All right, we can do that. No, I don't want it to think that, but we're also going to need to access it, so. Should we just make it public then? Nah, we'll just make getters and setters for it. So get is gateway. This will simply return this dot is gateway. And let's do them like this since they're related, is gateway. Well, it's going to be a bool, right? Boolean TypeScript, not in C#. And this dot is gateway equals value. Okay. This will work. This will work. So we're doing this. Then we're saying dot is gateway equals true. There we go. Okay. We got what we need in here. Good, 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 good. Probably should split that up into separate files. It's getting pretty big. Started off as being just like a little thing that holds data, but now not yet though. What was I doing? Yeah, I was, okay, that's right. I was trying to get to current node is gateway. If it is the gateway, if it is a gateway, we are done. We are done. So we break out of our while loop. Simple as that. We break out of our while loop, but. We need to call. No, we need, hold on. When I'm calling this, I'm expecting to actually get the link between the two nodes to remove. So I need to return that. That would be the easiest way to do that, is to do that right here instead of breaking or having like this temporary value here where I'm storing the current node. That's the last node, or I'm all going to do that in another function too. All right, but we're going to implement it here first. That was my idea, right? So what do we need to do? We need to recursive. Why? I'm surprised my little document here doesn't talk about that. Like, it gets us to the point where the algorithm finds the goal. But then what? Probably tells us about this later in. There. The goal cell is found, at which point the function terminates. Now, in order to get the path from the start of the goal, you just follow the arrows from the goal to the starting cell and reverse the order. Yeah, doesn't show us how to implement that though. Interesting. Not that hard to figure out though. Not that hard to figure out. I just wanted to see how they did it, but what we essentially need to do, and I'm pretty sure the smartest thing to do here is to do it recursively. So we start from our current node. Let's do that step by step. We start from our current node, and we get our previous node. So I need something to get that. Need the getter. This can just be a set, I guess. Previous node. There we go. And we'll put that here. And a getter. Get previous node. Return this dot previous node. Previous node. Type node undefined is not assignable to type node. Type undefined is not assignable to type node. Right. Can I do this in here? Looks like I can't. That's interesting. Must have the same type. I guess I have to do that. Yeah. That's kind of silly, but so it goes. Okay. Oh, now what? Property set previous node. Oh yeah, I can just do previous node equals now. Let's do it that way. And okay, I was doing all of that because I needed to get the previous node, dot previous node. Okay, now that I have that, I need to get its previous node. And then get its previous node. All right, that's basically what I'm trying to do. Object is possibly undefined. Right. So this definitely needs to be a recursive function, is what I'm thinking. Let's try to implement that right away, I guess. Here. Here. Get. What are we going to call this? Well, we're just going to call it recurse path for now. Find a better name later. Recurse path. Just give me the node that we're starting at. Then if node is undefined, we're done. We found a parent, right? Return. Okay, so we need to store, that's the thing. We need to store a list of indexes. Where do we store that? We store it in here. We don't have a choice. It needs to survive the recursion. So Let's call this path. Yep, let's call this path. Defaults to an empty array. And then we return our path. That's what we're doing. All right, so we're going to return a path. It's going to be an array of numbers. We'll just have the indexes. That's what we're interested in. Now, I think so anyways. We'll figure it out afterwards if that's not the case. I could store the actual node. I don't think we'll need to though. So if node dot previous node. So if the node where we're at doesn't have a previous node, that's our starting node. So we're done, return the path. If it isn't though, well, let's store our node dot, no, what do we, it's path. Path dot, how do I want to do this? I want to, yeah, we'll push it. It's basically a stack, right? Okay, so push the node dot index. What's wrong? Argument of type number is not assignable to parameter of type never. Type never. What? No. Come on. You know you're going to be a number array. There you go. Okay. So path dot push the node index to that thing, then just call recurse. I need to return recurse path using as our node the node dot previous node, and making sure to pass along the path. Yeah, I think we got ourselves a nice little recursive function that will in the end give us an array of the path using the indexes. Now we call this here. Going on, this is going to be a private function. We don't need the public to know about it. Shh. Okay. This dot recurse path. And then just give me the current node, which is our gateway. Then once we're done with that, we'll have an array. So we're going to call this the path. What do we do with it though? If I understand this correctly, we're pushing to our array. So the starting, right. So if we simply pop, we will get, that's our current node, right? That's not our current node. That's if we pop, we're going to get our starting node where the evil agent is. So let's do that. Okay. So this will be our what's it called? Skynet agent. So const Skynet agent, which is also our starting node. We already have access to that. So we don't need to store it. So let's pop, or we don't even need to pop it. Let's do this. So return, we know it's a tuple. This will be starting, right? Because we've kind of decided that it was always going to be the link that was closest to our user agent, Skynet agent. So starting node dot index starting node dot index and the other one is going to be path path dot length minus 2. Yes. That's not very explicit. So let's help the reader along. First node index, first node index in path? No, first second node in path. Index of second node, index of second node in path. Well, that's kind of confusing because, okay, you know what? Let's just leave it like that. For now, we might refactor later. So this, oh, that's interesting. Why doesn't it? Function lacks ending return statement and return type does not include undefined. Right. Because it doesn't know that we'll always end up finding this. Right? That's true. What if we don't find? Well, then we're going to throw, because that's not normal. Throw a new error, which we're going to call, couldn't find, could not find. A gateway. Basically, that's what it means, right? If we end the while loop and we couldn't find a gateway, there's a problem somewhere. But anyways, that allows our compiler to be happy. What are we missing here? We're missing something. Oh, I know what we're missing. Now this satisfies the requirement for the turn, for each game's turn. We're going to be feeding this to our code and game engine. But as we keep going, we need to make sure that we update our graph. We actually need to remove this link from our graph, from our network. And how do we do that? Oh, now what? What did I do? Property recurse path does not exist on type graph. Did you mean recurse path? I did mean that. Thank you. It's odd that I didn't notice that before. Okay, so let's start by removing our link. And it should be simple enough. We've got everything we need here, right? Remove link, node 1, node 2, boom. So we just feed that in. Just before returning, we do this dot remove link. And we have starting node dot index and path dot length minus 2 dot. No, I'm actually getting the number because it's path of indexes. Good. Now, since I'm using the same thing both places, shouldn't I actually make a variable for each? Nee. I probably should. So I will. Okay. Const starting node index. It's going to be this. Actually, that's not that much trouble, but the other one though really should. Freaking ugly. Const second node. Let's do that. Second node and path index. Yeah, whatever. That's what it's going to be. Naming stuff is hard. Okay. So we're removing our link. We are returning our thing here. Oh, I just thought of something. It might be smart. This is a public function. We're going to do it somewhere else. We're going to do it while the computer's thinking. The other player's doing their move. Yeah. This is better if we do that. Let's do that. See what's going on here. We're doing our game. Okay, you know what? Just before we go ahead and go further, let's test a little bit and make sure that we've got the stuff we've been changing works. Gonna start Quokka here. Don't care about you for now. Oh, let's see what we get. We're creating a graph of size 10. So it should create, I think I can use this here. There we go. Here's our 10 nodes in our node array with their indexes. Okay, this is gateway false. Marked false. Previous node false. Wait, how do I get marked? I have is marked. How do I access that? Oh, did I make a an actual functions instead of getters and setters? Might as well make getters and setters for this. So this will be a set mark. And then this will be a get mark. I just need to get the value here. Which is a Boolean. Value. Okay. Get mark. We're going to take this whole thing here, put it there. Return this stuff marked. Good. We just need to change this here. Starting node dot mark equals true. is marked. Can just be that, or maybe not. Right, just mark. Mark. I guess we should call it is marked. I don't know why I didn't do it that way before. It was kind of weird. Is marked. Is marked. Is marked. Is marked. Is marked. Is marked everywhere. Okay, this works. Now good. To change that to is marked. Here too. Here too. Oops. Is marked equals true. So we're marking the first one, and we're marking here. I think we're good. Oh, again, let's take a look at our nodes. Is gateway false? Is marked false? As we're starting, the index is 0. That's correct. Your index should be 5. That's correct. Good. Now we added a link between. So actually, let's forget about this one here. Oh no, I think we can do both. Let's do that. Add link doesn't return anything though, so let's get our graph. On line 9 should be different. We should have our connected nodes. All right, awesome. Index 1 is connected to our node 0, which is what we are expecting. And we should also have index 2, yeah, connected to our node 0. But we should also see this connection here, right? It's connected to node 0. That's right. To node 0, yeah. And this one should also be connected to node 0. Connected to node 0. Good. Now let's test. Let's test removing graph dot remove link. So we're going to remove our link between 0 and 1. Now see if that did the trick. Node 0 should only have, oh, seems like it still have those connections to node 1 and to node 2, but we just told it to remove 0, 1. So we've got a problem here. How about here? Oh, it removed it here. So let's take a look at our remove link. That's interesting. I've got this hard-coded. That is very interesting. Why did I do that? I don't know. But this should fix it. Let's see. Node 0 should only have one connection. Yep, Which connection is that? To index 2. That's correct. We didn't remove that one. And node 1 should have no connections. That's correct. Node 2 should still have that one connection to node 0. That's correct. Okay, so that works. What other public functions do we have here? Add link, we tested. Remove link, we just tested. Get node, I don't see how that could be wrong, but let's try it. Graph.get node, where we want node at index 2. Give it to us. Node at index 2. Oh, it's this one here. Get node connect. Index 2. That's right. Good. Okay. Okay. Awesome. Now. Now. The moment of truth. Let's see if we get. If our find best link to remove actually works. Okay, so it's saying could not find a gateway, and that would be correct because we didn't put a gateway in there. Now, did we? How about we add one? How about we say graph dot. Okay, so let's delete all of that stuff here. We know it works. Graph dot get node. Oh crap! I need to leave the links. Otherwise, we don't have a network. Remove these. Graph dot get. Well, let's make this a little more complicated, a network, right? Add link. Let's make a link to go from 1 to 3. And let's get these a little closer. Let's make a link to go from, oh, let's make this complicated, from 3 to 1, and then let's make one to go from C3 to from 2 to 4, boom, and one from 4 to 5, and 5 is going to be our gateway. Node dot is gateway true. Okay. Oh, it found something. Let's see. Let's see what we get. 0, 4. So it's saying, I think you should remove the link 0, 4 because it's the one that leads to the shortest path to our gateway. Would that be correct? Well, we've got 0 going to 1 and 0 going to 2. Then 2 goes to 4. Boom. And then 4 goes to our gateway. So that's 3 jumps, right? 1. Which one was it? Yeah, 1, 2, and 3. The other way around would be 0 goes to 1, 1 goes to 3. Oh, that's kind of dumb. 3 goes to 1. 3 goes to 2. Then 2 goes to 4. Yep, it still recognizes that this is the best way. Cool. Now, what if we had a dead end? Let's say this was no longer valid here. Zero to 3. There's no 0 to 3. What are you talking about? 0 goes to 1, 1's connected to 3. 3's connected to 2. 2's connected to 4. 4's connected to 5, and he's telling us 0, 3. What is going on? That doesn't make sense. Let's take a look at the path we end up with. That's what I love about Quokka. Look at that. Doop, 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 doop. So it started at, that's our end, 5. Before that we were at 4, okay. And before that we were at 2, makes sense. And before that we were at 3, right. And then before that we were at 1, okay. Right. And then what? Before that we were... Oh, and it stops. Right. Why does it stop? Where does it stop? If connect... where's my... If node.previous node return path. No. I have to push first. This will fix it. I have to push node.index. There we go. 0 and 1. And we've got our 1 all the way up to our 0. That's our entire path. Everyone's happy. Good, 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 good. Okay, so I think we're good to stop Quokka here. And just comment all that out. Now the one thing, okay, what I was going to do was the index of the node on which the Skynet agent is positioned this turn. Right, which is kind of important in order to call this. Right. So what we would do here is go network dot find best link to remove and put in SI, then that would return something which we would log out. Console.log. We're returning this. We're not actually returning this, that's true, because that's in the form of an array. And what we need to do is let's do that in 2 steps. Okay. Wow, what is going on with Slack? Just keeps beep, 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 beep. Close that. Okay. Network, find best link to remove. We're going to get a link array. We're going to call it link tuple, link. Oh, we'll just call it link. Const link to remove. And console.log. Let's make it a. Oh, I guess that didn't stop that now, did it? That's annoying. How do I Silence, please. Oh, you can't set yourself to away for all of your channels. You need to do them individually. That's just crazy. Okay, well, you know what? There. Okay. So, simply do this. Link to remove. Whoops. Oops. Like that. Link to remove. 0. Space. And the same thing with 1. There. Okay. Now, don't need this anymore. After we've done this, oh, I guess this is this isn't asynchronous code. Wouldn't make much of a difference, would it? But we're still going to do it in here. So once we're done with that, we want to actually remove that link. So we take our network, we do remove link, and this will be link to remove 0, and then link to remove 1. So that's taken care of. Oh, there's another thing, another kind of cleanup thing we need to do. Is now once we've run, once we ran this, our nodes all have like is marked set to true, and well, the gateway that doesn't change. So gateway's fine. The connected nodes is fine. So the previous nodes needs to go to be reassigned to undefined. So we need to go through. That's kind of a reset thing. And let's make a function for that. Let's make a should we? Yeah. We'll make it. We'll call it reset. Well, it's not actually. Nope. This should probably just be done inside find best link to remove. Nope, it shouldn't. It shouldn't because we're doing the cleanup here. Oh, I am. Yeah, I guess it could be because they're not necessarily related. So once we're done, once we've found, that is very interesting. Find best link to remove. I want this to have, once we're done with this, I want to clean everything up. Where do I call this? Could call it here, but what if we get to that here? So maybe the smart thing is to actually do it at the very beginning. Haha. Just before we call find best link to remove, we just clean everything up. Make sure we've got a clean graph. So let's call it clean graph. This not clean graph. And private clean graph is going to do what? It's going to go through the entire list.nodes for each node. What are you going to do? Node dot is marked. I'm going to need 2 lines. So let's do that. Node is marked is now equal to false. And node dot previous node is equal to undefined. So we make sure we've got a clean graph, then we start our algorithm. How's that? Then we don't need to call anything from main. We just need to worry about finding the thing. I can actually just remove it before. Right, that's what we're doing. No worries. We're committed. All right, how about we actually try this thing? Let me get rid of all these. Well, I've got this in error, so that's good. Don't really need this. That doesn't tell us much. Same with this here. Let's get rid of these console logs and errors and stuff. Do I have any in here? Can get rid of this. Okay. Everything should have updated. Encoding game. Right. We've got our graph class with the stuff we've added. I think we're in business. Let's try this. Oh, of course it didn't work. Time out. Your program did not provide an input in due time. What? How dare you? Why did it not provide a... Why? We are logging this. I mean... What if we just skip this for fun? Doubt that's where the problem is, but very interesting. Error could not find a gateway. Oh. Oh. I hadn't seen that. How are we getting this? How's that even possible? Are we not storing the gateways? Network get node EI is gateway equal true. This is an actual number. We're setting our gateway to true. Did we screw something up while refactoring? Let's get our friend back here. And let's get Quokka going. Sure seeming like we're finding it. Yeah. Okay. could be the problem? What could the problem be? Yeah. We're throwing an error, could not find a gateway. Are we? No, we're setting our gateway right here. Looking for Amy. Yo, here is your favorite exorcism mentor, Sleepless by. Hey, cool, man. If you look in the output, are you certain that a node says gateway true? Because I think it was supposed to make node 5 true, but didn't see it when you were scrolling through there. Well, actually, in this simple test, it would be node 1 probably, or there's only 3 nodes. So, and it's doing it. It should be doing it right here. This is where it should be doing it. Right. Our input, when we're parsing our beginning input, yeah, but look in your commented, uncommented example. Okay, and here, this one you're talking about. You want me to run it with Quokka? Oh, okay, see what you mean. Yeah, okay, I'll show it to you. I know it does, but I will show you. So if we look, that's like line 117. If we look at our nodes, node 5 is gateway true. See, so it does it properly. Otherwise, this wouldn't have worked. I don't think you were watching before, but I was just testing that a little while before. So I suspect, oops, I suspect that the problem is here. Maybe just the way I'm doing this. So we're gonna test it here, console.log, actually error. And let's get, actually let's look at our node. Let's look at get node EI. Let's take a look at it right after we're supposed to have set it to true. Okay. Let's do that. Thanks for the great feedback again on the, what was it, space age exercise. I'd been waiting like a month for that. Okay. So what are we getting? It's not even logging it? What? Am I missing something here? Did it update the code? Let's just make sure that it did. Yeah, I've got it. Console error network.getNode EI. Check the value of E. It might be a one-off error, as in the loop doesn't execute. That's a great idea, because it really seems like it didn't hit that piece of code at all, which would be surprising because most of this stuff here, most of what I've got here in main, that's actually boilerplate provided to you by the Coding Game. I didn't, this here, but yeah, I mean, the heck. Let's check it. So console dot error e. I'm going to check it. Well, I'm going to check it before. Makes sense, right? And then I'll check it. Let's see. Maybe I can check the value of EI too. So just give me a sec here. I'll actually make like that, and so that we know what all these logs are. Okay. What in the heck? I think I know what the problem is. In part. I think I know what the problem is in part is. So what's happening is this isn't a synchronous code, right? This is all happening in the while. The entire thing, the entire game is happening in the while loop. The while loop never stops to output anything. So it actually plays the entire game, and when the game is over, then it spews out the log. But since I'm throwing an exception in the middle of the game, I guess all those logs are being, I don't know, they're not being outputted or something. So what I'm going to do, just to test my theory, is to, instead of actually throwing here, I'm going to return, what am I supposed to return? An array. Okay, so I'm going to return an array of -1, -1. This will be what we're going to do here. Yeah, but if I turn off the game, oh yeah, that's true. I could have done that to at least see what the value of E was. But anyways, it's done. So there we go. Okay. So E is 1, which is correct. We only have one gateway. EI, the index of the gateway is 2. So this would be 0, 1, 2. Okay. Now, if we look at the node indexed 2, it is actually set as a gateway, right? True. Cannot read property, remove connected node of undefined. Yes, of course. That means that we're passing -1, -1 to our right, because I had changed that. Now that I'm passing -1, -1 instead of throwing. Let's see. If we're not finding it. Perfect. So far, so good. It probably means that your initial code is correct, but that the find best link to remove code or something it's calling is not right. Yeah. Yep. That's right. I don't know that that's perfect though. I would have preferred the other way around. This would have been an easy fix, right? Now trying to figure out why it's working when I'm doing this little scenario, but it's not working with an easy. Well, you know what? You know what? We could replicate this. Let's do that. So we've got 3 nodes, right? We know node 2 is true. We've got a link between 0, 1, and we've got a link between 0, 2. And our agent is at 0. Let's do that. This is the actual test case that we're being presented with on coding game. So start on current file. It's working. What the hey? It is. It's giving us what we're expecting, right? It's saying remove the link between 0 and 2, dude. That's where he's gonna go. Okay, but the loop runs it how many times? Now, are you talking about the this loop here, the game loop, if you will? Hmm. Okay, I see what you mean, and that might be the problem. I was just expecting the game to kind of exit the loop, or just, you know, stop or whatever once we've completed. But it might be that we actually need to break out of it ourselves. I don't know. This wasn't anywhere in the... Let's see. Each game turn, then this kind of tests provided, blah, blah, blah. Huh. Do you see the output? Output section in the docs. Oh, I didn't see that. Game input, oh, output, okay. A single line comprised of 2 integers and a separate space are the indices of the node you wish to sever the link to. Yep. Which is what we're giving it in our, right here, right? So are we seeing that? Is that what you mean? Well, it doesn't look like we're seeing it for each... We're not seeing it, and we should be seeing at least -1, minus... But here again, here's what's happening. I am perplexed. What are we missing here? I'm pretty sure we don't have to break out of that loop ourselves. But maybe. Let's try that. Let's just try doing that. See what happens. Because this game is basically one turn, right? There's just one link to remove. Oop. It's the only thing we need to do. Okay. It's still timed out. What the heck? Cannot read property, remove connected node of undefined. Oh yeah, that's probably just okay. Let's get rid of that. We don't even need to remove the link because it's a one turn. Yeah, just I know what that is. It's because we're going around again and trying to remove. Oh no, that wouldn't be. Anyways, let's run this first and see what happens. All right. Okay, so we're getting Damn. So that's it's not finding the output though, which makes absolutely no sense. We um we shouldn't be. So basically we're getting to this here, right? This is what's happening. But we shouldn't. We shouldn't be getting to this. We should be getting to this. At some point, we hit that current node is gateway, true. Then we do this, then we return. So when are we, okay, well, I'm gonna need to console log the, oh, wait, did that screw up something maybe? Oh, what am I doing? What? I'm retarded. Okay. And we're gonna stop Coca. Just to make sure that didn't screw up anything. I don't think it should have, but no, still the same problem. So, how about we just console log the shit out of this thing? Bad words. Sorry. Now, where are we likely to have a problem? Our problem is that we're getting to this. We shouldn't be getting to this. That's really weird. So what's the information we need to get? Well, we probably need to make sure that we are. Well, I'd be interested to see how many times we're calling find best link to remove. No, that doesn't make sense either, right? We're only calling it once because I'm breaking out of it right here. So that's not our problem. So we're only calling it once. Yeah, that's what I'm thinking too. Looking at the queue and see how it's being, and especially see which nodes get processed, read, marked. Yes, that is correct. Which is all really weird because we've replicated this scenario here and it all worked perfectly. But for some reason. So yeah, let's do that. Let's log the queue. Error. Let's take a look at our queue. Okay, and we're gonna get rid of. We know this is right? We don't need this anymore. We don't need that anymore. Let's get rid of the bloat. Don't need this anymore. And yeah, okay, let's run that. See what happens. Indeed, your scenario does work. So my thinking is that if the scenario works correctly, make sure that the indices are the same. Your test scenario is zero based. Make sure the input is the same. In the input documentation, this might be listed. It is, I'm pretty sure it's zero based. Yeah, see? Here's an example that they're giving us for this here. 0, 1, 2, 3. 0 is linked to 1. 0 is linked to 2. 1 is linked to 3. 2 is linked to 3. I don't know if you can see that on screen. It's pretty pale. Let me highlight it here. This is our initial input. That's an example of the initialization input for this puzzle, for a puzzle that would look like this. Okay, good. So now we're logging. The first thing we're putting in our queue, and only thing according to this, is index 1, which is incorrect. The user agent is at index 0. Okay, I think I know. Oh boy. Oh boy. Yeah, he is. I'm pretty sure. Hold on, hold on, hold on, hold on. I think I screwed something up here. The index of the gateway. What am I putting in there? SI. SI, the index of the node on which the Skynet agent is positioned this turn. No, that's right. It should be. Let's log it though, just to make sure. Just to make sure. Game information says agent is at position 1, which would make sense. Wait. Okay, hold on. Let's run it. Right. Agent's at position 1, which would explain why the first thing we're getting in our queue is index 1. Uh-huh. So would this be, okay, no, but that's fine. It's probably 0 is connected to 1 and 1 is connected to 2. And we've got our connected nodes here. We're not seeing them, but I'm sure it's 0 and 2. But if that is the case, let's just first thing, might be easier to debug this and just by changing our scenario here, user agent is actually at 1. See what happens when we do that. Might be able to replicate the problem right in here, which would be a lot easier to debug. Now, still works, right? What's going on here? I have a index1 false, blah, blah, blah. Take a look in here. So we're returning 1, 0. We're not returning -1, -1. Am I missing something here? Are the links 0 to 1 and 0 to 2? No, they wouldn't be. They'd be 0, 0 to 1 and 1 to 2. Let's make sure of that by logging our links, which I think I was doing before, but sol.error. And so let's just do N1, N2. It should work, right? One is linked to 2, one is linked to 0. The agent is on 1. So I don't think that's what I had. I had 1 is linked, what was it again? We'll do it in the exact same, 1, 2, 1, 0. So 1, well, that's essentially what I have, but whatever. 1, 2, 1, 0. Oh, doesn't change anything, still works. Yeah. Change the order in your example code. Yeah, was thinking the same thing. That's what I just did. Yet, it still runs. We're still getting an output. It's still... I am beginning to think that this might be some kind of problem in the way the code is being parsed to JavaScript. So let's take a quick look at... Wait, we've got something in red here. What does that mean? I don't think it's anything bad. It's just because we're... Oh, because we got a console log. It's probably, well, we got a console error. That's why we're console erroring the queue. So yeah, so we're basically, that's the only thing that we do here. It only runs once. Only runs once. It adds the starting node to the queue. It looks at if it's a gateway, it's not a gateway. It looks at its connected nodes. It sees that it's got a connection to 0. It sees that it's got a connection to 2. It pushes. Okay, now that's interesting. It pushes the connected node onto the queue, marks the node. Wait. Connected node is marked true. On line 78, log current node. Yeah, we could do that. Let's just put that in brackets so we have some sort of a. I'll put that here as well. It'll be easier to. Okay. Probably don't want to mark the connected node, but you want to mark the current node. Yeah, that's what I was just starting to think. You mark what you've processed, not what you've added. I agree. And how are we doing this? We're starting off by marking the starting node. Then we were doing our thing, path. This current node is queue shifted, which is actually the if current node is gateway. Ba, 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 ba. If connected node is marked. No, that's fine. That's the way to do it. We're only doing that to prevent actually processing stuff twice in the case where we have a, when we get back to a node that's already processed. So, right, this doesn't prevent us to, we're actually pushing them onto the queue. Now we loop back again. Our current node then becomes, let's say, node index 1. Or no, actually we're starting at 1, so it would be, let's say, node index 0. And then we're checking if it's a gateway. It isn't. Then we're checking if it's got connected nodes. It doesn't. And that's that. Go back again. And we're popping it off, right? We're shifting it. Yeah, okay, good. And we go back and we get to index 2, which is our gateway. We check if it's a gateway. Hey, it's a gateway. Cool. Let's do our thing and get the path. And this is where, I don't know, it's working here. Odd. Very odd. Which is why I'm thinking that it might be. I just want to take a quick look at what we're, because I've had some weird things happen in the way stuff was transpiled to JavaScript. Sometimes it does weird things. So it might be that Quokka is using like a different way to transpile my TS stuff, and it's running it fine. But the actual code that we're outputting to coding game is a bit different and ends up being problematic somehow. So let's see, current node shift, if current node is gateway, path, this recursion, second node in path index, blah, 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 return. This looks good. Okay. How about our recursion thing here? Oh, if path equals void 0, path. Well, it wouldn't be this anyways, right? It's just that we're actually not finding our current node as gateway. So yeah, let's, what were we trying to do here now? Logging our current node, right? That's the next thing we needed to do. So let's do it live in coding game. See what happens with that. Okay. Standard error stream, standard error stream. What? So just run it. So let's just run it with the test, see if you get the logs you expect. It might be an issue with the indices and the conversion. Like sometimes there are strings or and sometimes numbers or something like that. Yeah, that could be. I've been careful, I think, with that, but why am I getting two? Okay, this is one per turn, right? So this is the beginning. No, this is the beginning. I'm getting two logs because I still have my debug graph in there. Oh, yeah. Thanks, you're right. Okay. Let's run that again. Right. Okay. It would have been interesting though to see how that compared. Can I? Can't expand that. That's too bad. Anyways. So the queue. So we got our first index node. And then we just get current node once. And then that's it. But we should be getting more than that, shouldn't we? Each node should be going through it. Or at least the current node, the starting node, and it doesn't execute the loop again, so nothing is added to the queue. The while loop, why wouldn't it? Why wouldn't it? Queue.length is bigger than 0. Why wouldn't it? We are, let's see, okay, we're starting off with our starting node in the queue. So we have 1. Then we take the node out of the queue, and we call it current node. Then we check if it's a gateway. It isn't at the beginning, anyways. Then we look for its connected nodes. It's got 2. Cool. We are pushing them to the queue, both of them. And once we're done with that, we loop back here. Is length bigger than 0? It should be, and we should be going through this all. So if it's a transpilation thing, it's lines 86, and of is not being transpiled correctly. You can test this by changing to current node get connected nodes for each instead, yeah. Or I can actually look at the code and see right away if that's the problem. It would be this here. var I equals 0, a equals current node dot get connected nodes. I is bigger than a dot length I plus plus. That should work. I don't see why it wouldn't, but okay, we'll do what you say. We'll change it to a for each instead. I'll just comment out all of that. What's the shortcut again? Just for your sanity. Yeah. Keep forgetting the shortcut to just toggle block comment shift alt A. That's right. Good. Okay. Now we're gonna go current node dot get connect nodes dot nope. Oh, right. You know, that might very well be the problem because I'm actually I'm using an iterator here. Obviously, Quokka deals with it properly, but let me see here. I do have down level iteration true. I've got ES5 as a target. Wanna bet switching that to EX6 is gonna fix it? Let's see. If you use an iterator, you currently are creating a new one for each iteration created before the for loop. You know, that's true. No, hold on. Is that true? I'm creating it. Well, I'm not creating it. I'm getting it. I am creating it in here. No, you're right. I am. I am. Well, I'm just returning values. It's not like, I don't think it's computationally heavy. It's just like a basic get, isn't it? But anyways, let's just see if that. Okay, I see what you mean. But you know what? The fact that I'm switching to ES6 as a target might just fix our problem. I have a feeling. Nope, it doesn't. But, no, doesn't change anything. Didn't change anything. So, what you are suggesting is that we should basically do here. Let's call that const connected nodes, equals current node dot get nodes. Is that what you mean? And then just use that here. That doesn't, no, that's not what you meant, right? It is what you mean? Okay. Okay. Let's try that then. Nope. Want to look at what is it outputting now? Why is it still using this weird way? Why is it changing it to a for loop and not using my for of loop if I change the transpile to ES6? It does that no matter what, even if I'm targeting ES6? It always changes for of to a simple for loop? I never noticed that. Don't really see why, but okay. So let's go with your idea, your original idea of trying to make it using a for each. So I can actually keep this. So because of that, it will use for. You mean down level iteration boolean true? Not. I've got it set to true. False equals default, right? But I had it set to true. Should I set it to false? Is that what you're saying? I think if I do that, oh, I'm not doing the right thing here. Right. What does it say? Provide full support for iterables in for of spread and destructuring when targeting ES6 or ES3. So it really shouldn't make a difference since I'm targeting ES6 anymore. Could probably just get rid of that altogether. Might be a bug. Really? That'd be interesting. Line 94. Okay. Hold on. Yeah. Thanks. Let's just run that, see if we change anything by doing that, but no, it's still just getting the one current node. It's not looping around. And okay, so do you want me to try maybe converting that to an array and just using a for each? That could be something we could do, right? So what was it? Shift A, okay. Then I'm just gonna do, I think if I simply, can I do array not from an iterable? I think that would work. Seeing that the coding game has var, I think they run Babel on it or something like that, so it really doesn't matter what you put in your TS config, but that is just a guess. Oh, it'll actually work with just a bracket, see? I didn't think it would. Oh, with the spread, of course. Yeah. Didn't think about that. Love the spread operator, but I'm still not used to using it to its full potential. Okay, so we've got our connected nodes. Well, might as well reuse all of that. That's the only thing we changed, right? This should work. Yeah, love it. Use it to arify the DOM lists and stuff like that. Yep. No, then change a thing. Oh, except that now we're getting current node.getConnectNodes.slice is not a function. This simply means that they don't support full generators, I think. Huh. Yeah. Guess that would make sense. Let's just make sure we didn't screw up anything here. Running this again with our test here. No, we're still good. Yeah. So one potential fix to that. With target ES5, this is the intentional. Arguably, it is undesirable, and there are a number of issues relating to that and to down-level generator support in general. I know you have target on ES6, but it's still being done like that, so coding aim is overriding it. Yeah. Okay. I think the JavaScript engine they're using for encoding game now, it used to be SpiderMonkey. I think they switched to a version of Node recently. I don't know which one, though. So I don't know if that's... And honestly, I don't remember using an iterator on coding game before. Sometimes I like doing that, you know, in a class instead of returning uh, the actual array, and then the client code can just do whatever the heck they want with it with your array, right? I just return an iterator and say, here's the stuff contained in my array, but don't you dare start fooling around in my array, you know? I think your code is what I prefer, so keep doing it normally. I'm not sure what you mean. Oh, just not now encoding. Yeah, okay. Yeah, so that's what I'm going to do. I'm just going to simply return. What was our problem here? It was with this here. So we're just completely going to, oops. So we can do that. That's fine. We're just going to make sure that get connected nodes returns the actual array. Yeah, didn't create any problems here. Get connected nodes. Just give the people what they want. There you go. Okay, good. Let's comment that out like that. And let's run this. Ha, ha, ha. Well, well, well. Look at that. Look at that. It would seem that we have found the problem. Man, see, this is really annoying to me. My code was perfect, right? It's no, let's just clean this up. We've got console logs all over the place. At least we found the problem. Half an hour. Half an hour to figure out that coding game was doing some nasty stuff to my code. Don't want you polluting my nice output anymore. Oh, we need to get that back in. That is part of we need to get rid of the break. Oh yeah, let's test my theory that we don't need to actually break out of that while loop. Yeah, now that's true. It was a good learning experience because now if it ever happens again, my mind's automatically gonna go to that, and I might figure it out much quicker. Yep, see? Works. Success! Agent has been neutralized. Yay! Let's try it with several paths, see if my algorithm works. It does! Star shaped. It still does, because I'm awesome. Triple star. Yay! Boom! There we go. All done. Not bad. So now I'm just gonna. It's pretty neat, hey? How they've got like a graphical representation of the whole thing. Good. Oh man, I was supposed to stop at 11. Didn't see the time. So I'm gonna have to go. But thanks a lot, man, for your help. It probably would have taken me quite a bit longer to figure that one out without your help. It's like those movies with a hack interface. Yeah, that's true. Oh, that's a good one. All right, man. I'll see you around. Thanks again for stopping by.